So, Turing machine, as we were discussing, only the it reads the input string by moving left and right. For example, if you have the string like AABB, okay, AABB is there. So first it reads always from left to right. Whenever it comes across the symbol A, it is replaced it by X. Equivalent symbol for this A. See, for example, you can take the language. Language is equal to A power n and B power n, where n is greater than or equal to 1. The language, the set of the string may be double A followed by double B. So, or it is a triple A followed by the triple B, like that. So, 4A followed by 4Bs. Okay. So, whenever it comes across the A is replaced by X and it moves toward the right side in search of the equivalent symbol for this A. So, equivalent symbol for this A is B. Whenever it comes across B, it replaces B by Y and change the direction from right to left side. It start moving toward the left side. While moving left side, it moves toward the left side till it comes across the last symbol on the left side. Last symbol on the left side is generally represented with the X. Whenever it comes across the X, again it changes the direction from left to right side, and while moving this toward the right side, it is going to come across the symbol A. A is replaced by again X. A is replaced by again X and start moving toward the right side in search of the equivalent symbol, that is a B. So whenever it comes across the B, B is replaced by again Y. Okay. Once all these tape symbol, the input symbol is converted into these are all called as a tape symbols. So whenever all these symbols are converted from the input symbol to the tape symbols, so machine halts. So by changing the initial state to the final state, okay. After completion of all the symbols, input symbols, so it changes the state from initial state to the final state, where the machine is going to halt. Okay. For example, you can take Q naught AABB, right? So it always reads the symbol, which is, this is the first ID. This is the first ID. Okay. Q naught is reading A. So A is replaced by X. You can see here. So this A is disappear, in place of the A, X has come. Okay. And it is moving, it changes the state also. State changes and it start moving toward the right side in search of the equivalent symbol. So equivalent symbol is B. Okay. So now the B in the next this one, see, you can see this B is replaced by Y. First A is replaced by X. Equivalent for this is a first B. First B is replaced by Y. Okay. So these are the two ID. From this two ID, you can find the Q is, it is a Q naught. Q is a Q naught, and the input symbol is A. And output symbol is, so output symbol I have shown. So Q reads the tape symbol called as a tau. Tau, it is going to take you to the one of the state of the Turing machine, and it is replaced by tape symbol and direction. Direction may be moving left or right, moving left or right. See, you can observe here, it was before this symbol, now it has come after this symbol, hence it is a state is q1. In the second ID, state is q1. It whenever it comes across the symbol A is replaced by X and start moving toward the right side, and state is also changing from q0 to the q1. State is also changing from q0 to the q1. Whenever it is in the q1, it moves toward the right side in search of the equivalent symbol for this A. Equivalent symbol for this A is a B. So once it comes across the equivalent symbol B, so B is replaced by Y and it changed the direction. So it was moving toward the right side. Whenever it comes equivalent symbol B, it change the direction also from right to left side, and state is changing from Q1 to the C. Whenever it comes across this B, the Q1 comes across the B, so its direction is changing. It was here, now it has come this position. It has come this position. State has come this position. Okay, and it was Q1 here, now it is a Q2. So direction changes, state also changes from Q1 to Q2, and this symbol B changed to the Y. Symbol B changed to the Y. See, for example, you can take whenever Q1 come across the symbol B, so its state is going to change from Q1 to Q2. Okay, symbol is changing to the Y, and its direction is, it is changing the direction from right to left side. Okay, Q1 comes across B, so I am going to write here. So Q0, Q1, Q2, input symbol you can take A, B, right? A, B, you can write X, Y, blank. Q0 comes across A, so it is going to change the state from Q0 to the Q1, and A has been changed from A to X, and it start moving toward the right side. Okay, so Q0 is not coming across the symbol B. It is not coming across the symbol B. Q1 comes across the symbol B. So this is the position at this juncture. Q1 comes across the B. So state is changing from Q1 to Q2. See here, Q1 comes across the B. State is changing from Q1 to Q2. So symbol B changing from this B to the Y, and it start moving toward the left side. It was here, so it was here, now it has come, the state has come before A. So it was after A, so after changing from the B to the Y, it has come before A, hence it is a left movement. Okay, it is moving toward the left side, that's what I have shown here, left, L. Like that. In the Q2 state, it continuously moves toward the left side till it get the last symbol in the left side. The last symbol in the left side is it is a X. Okay, so here also this is the last symbol in the left side. Wherever it comes across the X, so this is not the last symbol here. So X is, if it is moving toward the left side, this will come the first. Hence, this is the last symbol on the left side. Okay, X are last symbol on the left side. Whenever it comes across X, whether this X or this X, so if it is moving toward this side, this X will be the last symbol on the left side. Last symbol on the left side. So hence it changes its direction from left to right. Okay, like this. Q2 comes across X. So whenever Q2 comes across X, so it changes the direction. It was moving toward the left side. Now it is going to change the direction from left to right. Okay, left to right. It was here. Now it has come here. That's what it is, a right movement. It is a started right movement, and state is also changing from Q2 to the Q0. Whenever it comes across, so Q2 comes across X, state is changing from Q2 to the Q0. X has not disturbed. X is as it is only. Okay, X is as it is. So as it is in the both the ID, and it is changing the direction from left to right side. Whenever Q2 comes across this X, so this much changes is going to happen. This much changes is going to happen. So again, Q0 A, as like this one, first one. Q0 comes across the A has been replaced. In the next ID, you can see A has been replaced by the X. A has been replaced by X, and state is changing from Q0 to the Q1. Okay, so this is Q0 comes across A, so Q0 is changed to the Q1. A has been changed to the X, and start moving toward the right side in search of the equivalent symbol. So equivalent symbol is this. Q1 comes across Y, it don't cares. So it continuously moves toward the right side. So Q1 is coming across B. Whenever Q1 comes across B, See, Q1 comes across B, state is going to change from Q1 to Q2. See, this is what the state is changing, and it was moving toward the right side. So direction is also going to change from right to left. Right to left, it was after Y, now it has come before Y. That means it is a move toward the left side. And this B has been changed from B has been changed to the, this is I think Q2. So this is Y. B has been changed to the Y. B has been changed to the Y. This B has been changed to the Y. Okay. So once it approach, when machine is in the Q naught, if it comes across Y, Q naught means it has to approach A only. So any other symbol comes, it's continuously moves toward the right side. Okay. While moving toward the right side, finally it is going to come across the blank symbol. So whenever it comes across the blank symbol, because it is a blind, so whenever it comes across the Q naught, machine is recording Q naught, and it comes across the blank symbol, it understands that all the input symbols are converted into the tape symbol. Hence, it halts in the final state, that is the Q3. It halts in the final state Q3. Okay. So from these IDs, these are the IDs. So from these IDs, you can get the transition function. Q naught reads A. So whatever changes happened in this, so Q naught state is, it is a Q1. State is Q1 I have taken here. Then A is replaced by X here. A is replaced by X. That's what I have recorded X. And it is moving toward the right side. So it is moving toward the right side. That's what it is a R. So from these two IDs, you can find Q1 is reading A, Q1 is reading A. So this A is kept as it is. So this A is kept as it is. Okay, that's what. So Q1 is Q1 only. Input side also Q1. So in the output ID also Q1. Hence I kept Q1 as it is. And this A, whatever it has read, so this same A is here only. That's what I kept A. Then R, right? It is moving toward the right side. If you are comparing these two IDs, Q1 is reading B. Okay. So that's what I have taken. It is a Q1B. Transition function is a Q1B. State is changing from Q1 to the Q2. So it is a Q2. And B is there. So B has been changed to the Y. That's what I have taken here, Y. And it was after A, now it has come, state has come before A, means that means it is a moving left side. So hence I have taken here left side. This is how you can convert the IDs, instantaneous description, into the transition functions. So if you are comparing these two, you can get this Q2A. So you can see Q2A. Q2A, it is in the next ID, this Q2 is there, next ID Q2 is there, and this A is as it is. This A is as it is. That's what I have written A, and it is moving toward the left side. It is left side. That's what L. So if you are taking these two IDs, transition function is, it is a Q2. So transition function is Q2, and in input symbol read by this Q2 is a X. I have taken X here. Okay. And the change, what is the changes? Q2 reads the last symbol on the left hand side. So it changes direction from left to the right side. Hence it is, you can observe here, it is a Q naught. So in this side it is a Q naught is there. And X is kept as it is, X is kept as it is. In the input ID as well as output ID, whatever X it is seeing, so X is kept as it is. Then it is moving, it was before X, now it has come after X, therefore it is a right movement. Hence I have taken the right movement. This is how we convert this instantaneous description into the transition functions. Once converted, so you can see Q naught A, Q1, you can record all the this what you can call it as a transition functions. Once you recorded the all these transition functions, see Q naught B, Q naught B, final one you can see Q naught is reading B, Q naught is reading B. So state is changing from Q3. Blank has been kept as it is. This blank has been kept as it is. Both the side blanks are there. and it has moved toward the right side. So it is a right. From these two IDs, you can get this last transition functions. So by making use of all these transition functions, you can construct the transition diagram. First transition function, it is a Q naught and output side is a Q1. That's what I have drawn the line here. The green line is there. So input is A and output side the symbols are X and R. The output side symbols are X and the right. A is replaced by X and it is moving toward the right side. For the next ID, input and output is a Q1 only. Input and output is a Q1 only. So input symbol is A, input symbol is A. In the output also, whenever it is in the Q1, it is only interested in the equivalent symbol for this A. A comes, it moves toward the right side. That's what it is a loop only. For the third transition function, Q1 reads B. So Q1 reads B. So state is changing to the Q2. State is changing to the Q2. That's what line between Q1 and Q2. Input is a B and output is a Y, and the direction it is moving toward the left side. Okay. Q2 on A. You can take Q2 on A. Q2 on A is, so whenever the machine is in the Q2, so Turing machine is in the Q2, it is moving toward the left side in search of the last left symbol. So last left symbol is X only. Whenever any symbol comes, it keeps as it is. Okay. So Q2 reads A, it keeps as it is. Okay. Whenever it is in the Q2, it is moving toward the left side in search of the X only. That is the last left symbol. Hence, any other symbol comes, it keeps as it is and moving toward the left side. So both the side Q2, Q2 is there, Q2, Q2. Whenever it comes across the A has been kept as it is and it is started moving toward the left side. So Q2 comes across the X. So state is changing from Q2 to the Q0, Q2 to the Q0. That's what this line. Okay. And Q2 has been, input is X, output is also X. So input is X, output is X, and start moving toward the right side. So this is moving toward the right side. This is how you can convert these, the transition function into the transition diagram. For the last one, you can take input side is a Q naught is reads B, that is a blank symbol. Hence, it understand that I read complete the input strings, or I converted all the input symbols into the tape symbols. Hence, it has to be go into the rest state. So in the rest state, neither it is moving toward the right side or left side. So rest state or halting state. So Q3 is the halting state. See, you can see here, it is a B, input is a B, output side is, it is a B comma R. This line is there, it is B is the input and this is the output symbols. This is how we design the Turing machine. Okay. For example, you can take A, B, B, C is there. Okay. A is equal to B is equal to C. Whenever it comes across the symbol A has been replaced by X, so it moves toward the right side in search of the equivalent symbol for the A. It is a B as well as C. So B is replaced by Y. B is replaced by Y. Q1 comes across B, so it is replaced by Y and it moves toward the right side in search of the equivalent symbol for the C. So Q2, whenever it is in the Q2, comes across the C. So C has been replaced by Z. Only two symbols are there. One is X and other one is Y. Immediately it moves toward the left side. Whereas here Z is the C is also there. So now the Q2 reads C. Q2 reads C. What happens? So Q2 reads C. C is replaced by Z, and it start moving toward the left side. Immediately it start moving toward the left side. Okay, that's what this and state is also changing from Q2 to Q3. State is also changing from Q2 to Q3. The next ID is this. This is the next ID. Okay. like that the Q3, if it is in the Q3 in the previous case, if it is in the Q2, it continuously moves toward the left side in search of the last symbol. In this case, three symbols are there. Whenever it is in the Q3, it start moving toward the left side in search of the last left symbol. So last left symbol I have taken again X only. See, continuously it is moving. Q3 is there, it reads Y till it is moving left only. Okay, Q3 reads A till it is moving left. Q3 reads X. Okay, please listen to me. Previously, Q2 reads X. So it was moving toward the left side. Whenever it reads the last left symbol, it changes the direction from left to right. And state is also going to change from Q2 to the Q0 because it has to be come to the this first state, that is a Q0. Okay, whenever it reads the last symbol on the left side, again it has to come back to the initial state, that is a Q0. Okay, so here Q3 reads X. See, you can observe here Q3 is reading X. So this is the last symbol on the left hand side. So it is going to change the state from now Q3 to the Q0, and X is as it is, and start moving toward the right side. So this is how, see, Q3 has come, it was before X, now it has come after X, means it has moved right side. And state is changed from Q3 to the Q0. Whenever it is in the Q0 reads A has been converted into X. A has been converted into X, and state is, because it is moving toward the right side in search of the B. When it search B, so state is should be in the Q1. When it search the C, the state should be in the Q2. Okay, so Q1 means Y comes, it never bothers. Y is left behind as it is. This Y is left behind as it is. So Q1 is comes across B. This B has been changed to the, you can observe here, this B has been changed to the Y. This B has been changed to the Y in the next ID. And state is also changed from Q1 to the Q2. Okay, Q2 comes across Z, it never bothers because Q2 means it is interested in only C. Hence, whenever it comes across the C, Q2 is reading C. Always the right hand symbols is read by the machine. So machine is, Turing machine is in the state Q2. Hence, it is reading C. C has been converted into Z and start moving toward the left side. Okay, so Q3 means so it continuously moves till it approach the last symbol on the left hand side. Now this is the last symbol on the left hand side. Immediately it changes the direction from left to the right. Okay, and state is also changing from Q3 to the Q0 because whenever it reads the last symbol, it is like a wall. Okay, whenever it hits in the Q3, so it is going to change. Hitting the Q3, so it changing the direction also, it is like a ball, and it is changing the state from Q3 to the Q0. Okay, this is how we develop the instantaneous description of the Turing machine. So once you get the instantaneous description of the Turing machine, Q0 A, input side it is a state is a Q0, input symbol is a. So this is what you can call it as a tau. So tau is A. And this ID you can get Q1. A has been replaced by X. That's what this X has come, and it is moving toward the right side. So it is moving toward the right side. This is what R you are getting. So next one you can see. For example, you can take this ID and this ID, Q2B. So Q2. So it is a state is Q2B. Q2B. So B kept as it is, and state is also same. As compared to these two IDs, state is same. This B has been kept as it is. That's what it is a B only. So and it is moved toward the right side. So it is a R. So this is how you can record the different from these IDs you can get this transition functions. Once you get the transition functions, see you can convert all these transition functions into the transition diagram. Finally, you can see Q0 B. So it is going to change the state from it is a Q naught B. Q naught B means it is a Q4 BR. So Q3 BR is repeated. Don't take this. Q naught reads the blank symbol. It understand that I converted all the input symbol into the tape symbol called as a X, Y, Z. These are all called as a tape symbols. A, B, C are called as a input symbols. So once when the machine is Turing machine is in the Q naught, it approach the B. It understand that all the input symbols are read by me. Hence, I need to be in the halt state. So now it is a Q4. Okay. So this is the for the language. This is the Turing machine for the language. L is equal to WWR, where W is the strings and it is belongs to the 0 plus 1 whole star. 0 plus 1 whole star. Okay. So W, if it is a W is it is a 0 0 1. W is a 0 0 1, whereas WR is reverse of it. Reverse of it is 100. Okay, so you can see here it works like this. First symbol is equal to last symbol always. This symbol is equal to this symbol, or this symbol is equal to this symbol. Okay, so here what it is going to do, it reads the this symbol and continuously moves toward the blank side. So I'll write here 0 0 0 1 1 0 0. After that we can have the blank blank blank. Okay, so for example you can take this 0 1 1 0. This is also WWR. Okay, in this case, the fourth symbol, first symbol is equal to fourth symbol. I can, as human being, I can easily make out the first symbol is equal to the fourth symbol. Whereas here, the first symbol is equal to the sixth symbol. But it is a machine, so it is very difficult to make out the things. Okay, so what it going to do? It know it the first symbol is equal to the whatever the symbol which is coming the before the blank. Okay, so what it is going to do? It converts first symbol into X and it moves continuously till it approaches the blank symbol. Whenever it approaches the blank symbol, it immediately turn left. Whatever symbol it comes across, so it finds that. So this is equal to this, and this first symbol is converted into the Y. Okay, so then it moves toward the left side, and X is there, it is approach X. Whenever it approach X, it changes the direction and state also. Hence again it is coming across the this symbol 0. Okay, so 0 is a input symbol and it moves toward the right side. Whenever it comes across the symbol B, this symbol is always equal to the last but one symbol. Last but one symbol. Hence, it approach this tape symbol Y. Whenever it comes across the tape symbol Y, changes its direction, and this has been converted into Y. This is X and this is Y. Okay, next, whenever it comes across the last symbol on the left side, changes its direction. This will be equal to always this in the case of the WWR. One is converted into X and this one into Y. Or you can take, so 0 is equal to 0. You can take 0 is equal to 0. Q naught reads 0. It has been converted into X, and the Q1 reads 0. This is equal to this. So 0 is this 0 is converted into X. This 0 is converted into Y. This one is converted into X. This is equal to this. So this has been converted into Y. This is equal to this X, Y. Whatever ID you are writing now, according to that, this you can get the transition functions. See, what assumption I made, this is equal to this, or you can take this is equal to this is equal to this. How do you write this ID? According to this ID, you can have the transition functions. Okay, so Q1 comes across the first 0, it is X. This 0 is equal to this 0, so this is replaced by Y. You can find here. Okay, next, Q1 comes across 1, 1 is replaced by X. 1 is replaced by X, this one is replaced by Y. See, you can find here. Okay. Again, this one, this 0 is equal to this 0. So this 0 is replaced by X, this 0 is replaced by Y. Okay, like this. So Q2 comes across the X. So as I told, the X is the whether this X or this X, Y, whenever it comes Q2, either it comes across the X, it understand that whether it comes this or this. See, wall or wall only. Whether the three walls are there, this will be, you can reach only this wall, and you have to reflect it back. Okay, like that, whether this X or this X, if three X are there, it cannot reach the last symbol. Hence, this will be treated as the left last symbol. This is the left last symbol. Hence, it comes across the last symbol, changes its directions, and reads the symbol Y. Y is a tape symbol. Continuously, it moves toward the right side. Whenever it comes across the blank symbol, so it needs to be changes into the halt state. Hence, Q0 is now going to change to the Q3. According to this IDs, I developed the transition functions Q0 on 0. So either Q0 on 0 or Q0 on 1. Sometimes, see, this 0 has been converted into X. Sometimes this 1 has been converted into X. That's what. Q0 on 0 or Q0 on 1, it has been converted into X, and it is moving toward the right side. Sometimes 0 has been converted into Y. So in this case, the 1 has been converted into Y. The 1 has been converted into the Y. That's what Q1 0 or Q1 1. So it is a Y. One time it has been converted into the 0. One time it has been converted into the on 1 has been converted into the Y. That's what it is. And 0 1. See, for this 0, it has moved. It has been converted into the Y, and it was here. Now it has moved. This position means that is what? Left side. So this is the left side. This is how we convert these instantaneous description into the transition function. From this transition functions, you can convert the transition diagram, as like I have shown it in the first example. This is the Turing machine for the language WWR. Okay, next question is question may be asked a non-deterministic Turing machine. Okay, so in the case of the non-deterministic Turing machine, you can call in the case of the non-deterministic finite automata, NDF. Okay, non-deterministic DFA and NDF, non-deterministic finite automata. Generally, we write Q into sigma, it is equal to 2 power Q. Whereas in the Turing machine, we write the definition for the transition function is Q into X is equal to this, in the case of the deterministic Turing machine. Whereas in the case of the non-deterministic Turing machine, it is like a 2 power X. So deterministic, how do you write? Q transition function, Q tau tape symbol, we write it as a Q tau into direction, either left or right, or you can write D. D is the direction, so left or right. Whereas in the case of the non-deterministic, so it is a 2 power this. It is a 2 power this. It is a deterministic Turing machine. If it is you are writing 2 power this output, so this will become the non-deterministic Turing machine. So it has a this in the case of the non-deterministic Turing machine. So for the same tape symbol, you can find the different output, as like in the NFA, non-deterministic finite automata. For the same symbol, you may have the zero outgoing transition or more than zero outgoing transition. So in the case of this, for example, you can take uh, Q1 reads A, so it may take you to the symbol B, and it is moving toward the left side, and state is changing from Q1 to Q2. Even same symbol, the input is read A may be changed to the C, and it may change the direction also, right side. This is possible in the case of the non-deterministic Turing machine. For the same symbol, you can have the, so this is the input symbol, and these two are the output symbol. Like A has seen, it has been converted to X and right. So A seems it may convert it into Y and the right. So in the case of the deterministic, whenever it sees the A, okay, A has been changed to the X and state is changing from Q0 to the Q1 only. Whereas in the case of the non-deterministic finite automata, A is changed to the either to the X or to the R, and either it may move toward the right side or it may move toward the left side. This is possible in the case of the lot of options are there for the same symbols. So such a finite automata, we call it as a non-deterministic Turing machine. See, I'll show you the question bank for the third internal also. So there you can find the non-deterministic Turing machine. These are the this is the question bank for the third internal. WWR is there. So I had already discussed AN, BN, CN. A is replaced by X, B is replaced by Y, C is replaced by Z. Okay, so non-deterministic Turing machine also there. So in the exam also, in the question paper also, you can find non-deterministic Turing machine. Question is asked many times. So I'll show the question paper. So many times a question has been asked on the non-deterministic Turing machine. So just you write the power. Non-deterministic Turing machine, somewhere I find it. I found. So where it is. Non-deterministic Turing machine. See, you can find here. Huh? So non-deterministic Turing machine is one. The output has, see here only in the case of the NFA, sorry, in the case of the deterministic Turing machine, Q has only one output. Q reads tau, so it is going to take you to the Q, tau, and the direction. L or right side. Only one, in one state. Okay, any one state of the Turing machine. Whereas in the case of the N Turing machine, so Q reads the same symbol. It may take you to the options 2 power Q, tau, and the direction and the direction, or you can write left comma right, left comma right. So lot of options are there. If you are writing this much, so you can have the 5 marks. You can easily get. This is about the non-deterministic Turing machine. Next one is multi-head Turing machine. So before covering the multi-head Turing machine, let me cover the offline Turing machine. So in the offline Turing machine, what happens? Any changes is happening. It is not happen in the input tape. For example, if you have the symbol like this, A, okay, A, B, B. In the normal Turing machine, what happens? So it has happens in the same tape. A is replaced by X, B is replaced by Y, this A is replaced by X, this B is replaced by Y. In the case of the offline Turing machine, what happens? This inputs tape is not at all disturbed. So whenever it reads A, it reads the read head reads the A, It is a finite controller. If it reads A, okay, so it uses the separate tape. It uses the separate tape. In the case of the offline Turing machine, it uses the separate tape. This whenever it reads the first symbol, this is empty. Whenever it reads the first symbol, now the X has comes here. Okay, whenever it reads this B kept as it is. So please make a note. So this is the input tape. In the input tape, these are not converted into the tape symbols. So extra tape is considered here. This is one Turing machine in the case of the offline. Whereas standard Turing machine, only one input tape is there. There itself we can store the input symbol as well as the tape symbol. Whereas here the input tape is different, which stores the input symbol, and the tape is another tape has been taken, which replace the tape symbols. A by X, this B by Y, B by Y. Okay, then again A by X, this B by Y. So this type of the Turing machine, we can call it as a offline Turing machine. See, question is there in the external also, offline Turing machine, question is there. So if you can go through this, somewhere I found it. So offline question is there, offline Turing machine. So this is what the offline Turing machine. Okay, I'm not finding the question, but question has been asked one or two times, offline Turing machine. So instead of overwriting this input symbol by the tape symbols, so separate tape is used for the input symbol as well as the tape symbol. So such a type of the Turing machine, we can call it as a offline Turing machine. See, you can find here. So this is for storing the input symbol, and this is for the storing the tape symbol. So such a finite automata, we can call it as a offline Turing machines. Many other Turing machines variations. Okay, question will be asked. Write the variations of the Turing machines. You can write multi-track, multi-tape, multi-head, multi-dimensional tape. The offline Turing machine. We'll see what is this multi-tape Turing machine. So here, see, it consists of multiple tapes. It consists of in the standard Turing machine, only one tape was there. So here it has a multiple tapes. It has a multiple tapes. Okay, and it has a finite controller. Only one finite controller is there. Only one finite controller, and multiple read heads are there, which reads all the cells of these multiple tapes. So it has a multiple read write heads. It has a multiple read write heads. See, because of this multiple read write head, x is it is a x power n. For example, the three tapes are there. If it is a, you can store here it as a. Okay, so here it as a B. Here you can store it as a C. Okay, so the transition function you can write delta of q. Standard, what happens? Delta of q into single symbol. So it is going to take me to the, so q, then a is replaced by x, and it was moving toward the right side. Okay, so this is the tape. This is the tape. Okay, blank is stored. Blank is stored in this. By default, all the cells are stored the blanks. So this are stored the blank. These are all stored the blank. Okay, see, in this it is a reading, q is reading. In this tape it is a, in this it is a, so in this it is a b, so in this it is a b, in this it is a c, in this it is a c. So maybe the head is moving toward this side. A is replaced as a x output side, Q is a Q, A is replaced as a X, and B is replaced as a Y, C is replaced as a, for example, it is a Z, and in this case, it is a moving toward the left side. Hence, for the first case, it is a L. First case, it is a L. If it is moving toward this side, so after changing B to the Y, if it is moving to the this cell, so it is a R. It is a R. Okay. If it is moving to the this cell after converting C into Z, if it is moving to this cell, so this is also R. That's what he has taken here, left and right to the power n. So power n is, so it is a 3. Power n is a 3. In our example, it is a 3. This n is also 3. N x power n means, so x power 3. 3. These are 3 are there. Okay. A cube is what? It is a. So it is a, in general, symbol is there. Symbol power 3 means 3 different symbols. That's what. In the case of the multiple standard Turing machine, what happens? There is a no n. Whereas in the case of the multi-tape Turing machine, we can have the multiple symbol on the input side. Whereas in the standard Turing machine, only A is there. That's what, Q into tau. Q into tau or X. He has taken X. Okay. In the case of the multiple 3 tapes are there, n value is 3. So even left and right. So directions also, it is 3 directions are there. That's what it is, L comma R power n, where n is 3. Maybe it is a left, right, like that. So this is regarding the multi-tape Turing machine. So questions are there. You have the hard copy. Please go through it. I cannot switch again back to this multi-tape Turing machine. See, you can hear multi-tape Turing machine is there. Okay. So multiple Turing machines, you can write this answer. See, you can write this. See, only I have shown the 2. N is 2. Okay. Q naught is, in this case, it is a pointing 0. That's what I have taken 0. In this case, it is a pointing 1. This 0 is replaced by X here. This 0 is replaced, the same tape. This 0 is replaced by X, and it is moved toward the left side. 0 is replaced by X, and it is moved, first time it is moving toward the left side. 1 is replaced by Y, and it is moving right side of the Y. That's what it is here. It is a right. Okay. This is how the multiple tape Turing machine works. So only thing is that multi-tapes are there. Finite controller is only single. So it is a Q naught only, input side as well as output side. Q naught state is changing to the Q1. That's what I have taken here. It is a Q1. Okay. So question is asked one time on the church Turing thesis. Only thing is that the Turing machine is defined as a abstract representation of the computing device, such as hardware in computers. Alan Turing proposed the logical computing machines, Turing expressions for Turing machines. This was done to define algorithm properly. So Church made a mechanical method. Okay, Turing made a logical computing machine. So before this Turing, the Church is a scientist name. Turing is also a scientist name. This Church also developed one mechanical computing model, automated model. So Turing developed a logical model. It was working like a computer only. In the earlier days, no computers were there. So this Turing machines, they were treating like a computer because it was performing operation what the computer was performing. That's what the Turing machine is also treated as a one of the computer. And Turing is a scientist name. He is the father of the our computer science and engineering. For computer, the father of computer is a Charles Babbage, whereas the father of the computer science and engineering is the Turing is the father of computer science and engineering. So before Turing, I think in the year 1930, the church has developed one mechanical model which was behaving like the earlier days. It was they were treating it as a automated machine. Automated machines are called as a computer present days. So they started calling this as a computer. The mechanical model was calling as the computer. So mechanical method named as a M for manipulation of the strings by using logic and the mathematics. So he developed a mechanical model. It was behaving like a computer only, and he uses logic and mathematics in order to operate this mechanical model. This method M must pass the following statements. A number of instruction in M must be finite because it is a finite machine. So it was performing operation in the finite time. That's what number of instruction in M must be the finite. Output should be produced after performing a finite number of the steps. Okay, it should not be imaginary. It can be made in real life. It should not require any complex understanding. Using these statements, Church proposed a hypothesis called as a Church-Turing thesis that can be stated as the assumption that the intuitive notions of computable functions can be identified with partial recursive functions. In 1933, this statement was first formulated by Alonzo Church and is usually referred to as Church thesis or Church-Turing thesis. One or two times question has been asked on the church Turing thesis. Just you can write the description, this one only. Okay. So this is regarding the church Turing thesis. The next one is Turing machine halting problem. Okay, so as I told, whenever the machine is in the initial state, okay, if it records the blank symbols or it reads the blank symbols, it is going to halt. It is going to halt. Okay, so what is this the halting problem? We will see. Does the Turing machine finish computing of the string W in finite number of the steps? The answer must be either yes or no. Okay, so any Turing machine you take, by reading the string, if it is recording the final state, we can say the string is accepted by the design Turing machine or Turing machine. Okay, so after reading the last symbol of the strings, only anyhow, the machine is going to halt. Okay, whether it is halting on the double circle or the single circle, so the machine is going to halt. Okay, so what do you mean by halt? If it reads the last symbol of the string W, if it halts, if it is halting in the double circle, that is what you can call it as a the string W is accepted. So whether the string is accept or not accept, so it is going to halt. So where it is halt, that is secondary. Maybe it is a halt on the intermediate state. Maybe it halts on the final state. So if it is halt after reading the last symbol of the string, if it is halts on the final state, you can call it as a string accepted. If it halts in the somewhere after reading the last symbol of the string W, if it halts in the intermediate state, we call it as a string is rejected. Okay, so pictorially, the halting machine of the Turing machine is you can give the input string W. Okay, HM halts on the input W. Either it is a yes, yes means so it is halted on the final state of the Turing machine. That means the string is accepted. Even it accept also, the machine is going to halt. So even the string is not accepted, no, the machine is going to halt. So this is the problem, one problem, halting problem of the Turing machine. So it is called as a Turing machine halting problem. Pictorially, you can represent like this. Okay. So inverted halting machine, string is accepted. Okay, inverted. So what happens? String accept, it halts. Okay. So in the case of the inverted string accepted, it should not halt. It should not halt. See, you can put it in the infinite loop. String is accepted. In the case of the inverted, the machine is not stopping here. So it is a qi to qj, qj to qi, q. So even though string is accepted, but machine is not halting. Whereas in this case, normal halting machine, string accept, it halts. Okay. So in the case of the inverted, two more states have been included on the yes side. If it is a no, it halts. In the case of the inverted Turing machine. Okay. The decidability language. So if we have the question paper, please go through the question paper. Question will be there for 5 marks. Language decidability. Okay. What do you mean by language decidability? Right? Any language. So language is a set of the strings. Okay. So any language, if it has a set of the strings, so is accepted by the Turing machine. So such a language, we call it as a the decidability language. Okay. The meaning of this language decidability is whatever the strings are there, each string is accepted by the Turing machine. So for example, pictorially you can represent. So it is whatever the strings are there in the language, it is observed by the Turing machine. It is observed by the Turing machine. Okay, that means the strings of all these languages is going to accepted by the Turing machine. See, accepted by the Turing machine. So, such a language, we can call it as a language decidability. Language decidability. So that means the set of the strings are there in the language. Each language or the each string is accepted by the Turing machine. A decision problem P is scheduled if the language L of all S instant of to P is decidable. For example, you can take maybe it is a decision on the halt. Okay, so for example, you can take the string W. If the W is accepted, it is going to terminate. String is accepted. Okay, so W is a different one, so it is going to take you to the intermediate state. Hence, you can call it as a the rejected. So whether it is a reject or accepted, the machine is going to halt. Where it is going to halt? If it is accepted, it is going to halt to double circles or final state. If the string is rejected, it is going to halt. So on the intermediate states. So in the both the cases, the machine is going to halt. The machine is going to rest. Because why it is resting? So it is reading the last symbol of the string. Find out whether the following problem is decidable or not. Is the number m prime? For example, numbers are given. Divide the number m by all numbers between 2 and square root of the m starting from 2. If any of these numbers produce remainder 0, then it goes to the rejected state. Okay. Otherwise, it goes to the accepted state. So, here the answer could be made by yes or no. Hence, it is a decidable problem. Okay. Decidable problem is one. I'll give the definition of the decidable problem. Decidable problem is one. Any problem, if you are solving it in the finite time, so such a problem is called as a decidable. So the undecidable problem has a solution, but we are not finding the solution in the finite time. Okay, finite time. Such a solution we can call it as a the undecidable problem. Okay, both are solvable. So some of the problem we know the solution. For example, you can take x and y. If it is a x plus 10 is equal to, it is a 12, we can find out the x values. Okay, you can easily find out the x values. So it is called as a the decidable. You can call it as a decidable. So we are finding the x values. Okay, we know how to find this. So what we will do, x is equal to, we will place 12 minus 10. Now we know how to find the value of the x. So that's what it is, a decidable. Okay. For example, x plus y is equal to 20. So two are unknown values are there. Two unknown values. I cannot say these two cannot be resolved, but they take their own time to find the value of the x and the value of the y. Such a problem, you can call it as a the undecidable. The problem is that in the case of the decidable, within the finite amount of time, you can find the solution for the such a problem. But this problem, I cannot say you cannot solve it. You can solve it, but within the prescribed time, we cannot find the solution. Such a concept we can call it as a the undecidable. Okay, many times questions are there on the decidable and the undecidable. Okay, so please go through it, decidable and undecidability. So problem can be solved. Okay. Given a regular language L and the string W, how can we check if W belongs to the language? Very simple. W belongs to the language if it is accepted. Okay. If it is accepted by the Turing machine. Okay. Accepted means double circle. I can write W belongs to the L. It is a non-regular if the design Turing machine is not accepted. See, if it is not accepted means intermediate state. Intermediate states are represented with the single circle. Therefore, the W is not belongs to the language. W is not belongs to the language. Okay, undecidable language exactly opposite to the decidable language. Okay, so here whatever the language is there, we do not have the Turing machine for the language. See, non-Turing acceptable languages. See, this part is you can call it as a decidable language. That means whatever the languages we defined, it has its own Turing machines. So some languages are there, for them we don't have the Turing machine. Such a language we can call it as a undecidable language. The definition you can see, for any undecidable language, there is a no Turing machine which accept the language and makes a decision for every input string W. Very simple, undecidable languages. These are the languages. For them, we do not have the Turing machine. Okay, so for example, you can see in the case of the finite automata, this L is equal to A power n and B power n, where n is greater than or is equal to 1. You cannot design the finite automata for this. We cannot design the finite automata for this. So such a language, you can call it as a the non-regular language. We proved it is a language is a non-regular. Okay, it is a non-regular. With the pumping lemma, we proved it. The language is a non-regular. We cannot design the finite automata. So in the Turing machine also, some of the
Sir,
languages are, yes.
can we continue
Yeah.
this in the next class?
Next, I'm not finding time because tomorrow is holiday.
Sir, it's already 10:30.
Yeah, let me finish at 11 o'clock.
We didn't have dinner yet.
Oh, then when
Sir, tomorrow you can keep it online only, no, sir.
tomorrow is holiday, this almost all girls are celebrating the festival.
Well, sir, you
Their
have to
parent,
get up, sir, tomorrow.
no, their parent will object, no.